All right, welcome to Unit 3. This is Unit 3, Lesson 1, our Intro to Trigonometry, or probably, hopefully, a reminder of what you've learned so far in Algebra 2 Trig and Geometry for your trigonometry. So let's do a little bit of warm-up. You might want to pause now and just do this on your own, see how much you recall. If you are having a hard time or you don't remember your trigonometry, then you might want to listen along with this entire video or look up some stuff on Khan Academy. But everyone who's in this honors level pre-calc we expect you to know all of this information from the warm-up, but I'll take you through it anyway. So this is about right triangle trigonometry here at the beginning. We have this little word, SOHCAHTOA, to help us remember that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Remember, in your right triangle, your right angle is here, your hypotenuse is the longest side, which is opposite the right angle, and your opposite is opposite the angle that's given, and adjacent is the other side that's right next to the angle. So the hypotenuse and the adjacent side create the angle that we're referring to right here. Okay, we have our three reciprocal functions. So 1 over sine is equal to cosecant, therefore cosecant equals hypotenuse over opposite. 1 over cosine is equal to secant, so that equals hypotenuse over adjacent. And 1 over tan equals cotan, so that's adjacent over opposite. We really don't focus on opposite, adjacent, and hypotenuse at the pre-calculus level. We tend to look at the unit circle and put everything on a coordinate plane. So instead we're going to be looking with the x-coordinate, the y-coordinate, and the radius. So we're going out to a point out here in a coordinate system. You go to the right so many units, which is called x because that's horizontal. Then you go up so many units, which is the y-coordinate, and that gets us to this point right here. We can create a right triangle. The distance from the origin to this point xy is called the radius because, again, we're making a circle going all the way around. Okay, terrible circle, sorry about that, but hopefully you get the idea, right? It's a circle going around where the origin is the center of the circle. Okay, so if instead of using opposite, adjacent, and hypotenuse, we use x, y, and r, then sine is equal to opposite over hypotenuse, which is y over r. Cosine is adjacent over hypotenuse, which now is x over r. Tangent is opposite over adjacent, which is y over x. And then we reciprocate, so we're just turning all of those fractions upside down to get the reciprocal function. All right, moving along. Number 1, rewrite each trig function in terms of x, y, and r to show that sine of theta equals 1 over cosecant of theta. Well, 1 over cosecant of theta, that means we're just going to do 1 over r over y because that's what we have here, so we put that in. And then that's 1 divided by r over y. So we take this, reciprocate it, flip it upside down, which is how we get y over r, which is then equal to sine theta, as we can see up here. Sine over cosine, so how can we rewrite this? Well, we substitute in for sine, which is y over r, substitute in for cosine, which is x over r. Of course, your r's and your denominators are going to cancel, or we take this, flip it upside down and multiply, so our r's cancel, so we are left with y over x. And y over x, we can see up here, is equal to tangent. So now we know, we've just proven that sine over cosine equals tangent. Sine theta over cosine of theta equals tangent of theta. Finally, this last one, rewrite cosine of theta equals x over r and sine theta equals y over r to solve for equations x and y. So all we're going to do is multiply each side by r. So when we multiply each side by r, we would get x equal to r times cosine theta, and y equal to r sine theta. Well, if we just solved for x and y, we can now put that x and y into the Pythagorean theorem, right? We know here that x squared plus y squared equals r squared, right? A squared plus b squared equals the hypotenuse squared, c squared, so it's the same thing except we have an x, y, and an r. Well, let's substitute in x is going to be r cosine theta, y is going to be r sine theta. So when we do that, we get r cosine theta squared, r sine theta squared equals r squared, so we just substituted in here for x and substituted in for y. So this is my x, this is my y. And so when you square, you have to square the r and square the cosine. Square the r and square the sine. So we have r cosine squared theta plus r sine squared theta equals r squared. Well, if we factor out the r squared on the left-hand side, we would get an r squared out here, and then cosine squared plus sine squared, and that equals r squared. If you move everything to the same side, then we factor out our r squared. We get cosine squared theta plus sine squared theta minus 1 equals 0. We can divide each side by r squared. So cosine squared theta plus sine squared theta equals 1. I guess you really didn't have to move everything over, right? You could have, let me just erase what I have. We could have just divided each side by r squared, but when we're getting to our simplifications, we're not going to want to divide on each side like that. So that's why I was trying to factor. But regardless, you're going to get r cosine squared plus sine squared equals 1. Okay, now that we know that sine squared plus cosine squared equals 1, we usually put sine squared first, we can create two other Pythagorean identities. So if we have sine squared theta plus cosine squared theta equals 1, we can divide each side by sine squared, or sorry, each side by sine squared. So when we do that, then we end up with 1 plus cotangent squared theta equals cosecant squared theta. So this is a second Pythagorean identity. We would do the exact same thing. Sine squared plus cosine squared equals 1, but this time we would divide by cosine squared. So we would get tangent squared plus 1 equals secant squared. So sine squared divided by cosine squared is tangent squared, and this is 1, and then this is secant squared. So hopefully those are looking familiar from last year. Moving on, determine the quadrants where the following is true. Okay, so we have quadrant 1. Remember, we go counterclockwise. Quadrant 1, 2, 3, and 4. We have this little saying, all science teachers are crazy, or all students take calculus. But what that is, it means that all trig functions are positive in the first quadrant. Sine and cosecant are positive in the second quadrant. Tangent and its reciprocal function, cotangent, are positive in the third quadrant. And cosine and secant are positive in the fourth quadrant. So ASTC is where these functions are positive. So knowing that, when will cosine be positive and cosine be negative, or opposite signs? Or cosine be negative and cosecant, sorry, I said cosine. Cosine be positive, cosecant negative, or cosine negative, cosecant positive. So opposite signs. So that would be here in quadrant 4, cosine's positive, cosecant's negative. And it would also then be in quadrant 2 because sine or cosecant's positive and cosine's negative. So that would be 2 and 4. Where's cosecant negative and tangent positive? Cosecant is negative and tangent is positive. Well, that's got to be quadrant 3 because that's where tangent's positive and the other one's negative, because in quadrant 1, tangent's also positive, but so is cosecant, so that wouldn't work. Sine and cotan have the same signs, so when will sine and costan have the same signs? Well, it's going to be in quadrant 1, they're both going to be positive, or that's going to be in quadrant 4, where they're both negative, right? So quadrant 1, where they're both positive, or quadrant 4, where they're both negative. Okay, the unit circle. The unit circle you're going to use a lot still throughout this entire unit. You should have gotten to know it pretty well in Algebra 2 Trig. So your unit circle is a circle with a radius equal to 1, right? So this point right here, this represents the radius. So that is 1 unit. Well, we want 1 to the right, 0 up and down. So that means that point is 1, 0. Here up here, here's another clear distinctive radius. If that's a length of 1, we went right and left 0, up 1. Here's another one. Right, we went left 1, up and down 0, and then we go down here, and that is right and left 0, down 1. So those are all with a radius of 1. Well, no matter where we go, we're going to have a radius of 1. So this is still a radius of 1. But you're going to create your right triangle. You're going to cross horizontally the x-axis and up the y-axis. So if this angle right here is pi over 6, well, you learned in geometry that if this angle is pi over 6, which in geometry we called that a 30-degree angle, the side opposite the 30-degree angle we would call x. The hypotenuse is twice that, and the leg next to it is x root 3. So we can just use ones. So this is a 1, this is 2, and this is 1 root 3. So to get my ordered pair right here, I would go to the right root 3 and up 1. But we can't do that because we need to have a unit circle with a denominator, or sorry, a radius of 1. I just made my radius 2, so that doesn't work. So how can I make my radius equal to 1? Well, if this has to be 1, then that means this length is half of it, right? If this is equal to 1, then x is equal to 1/2. And so this right here is equal to 1/2 root 3, or root 3 over 2. So we go to the right root 3 over 2, and we go up 1/2. So we just learned up here that if radius is equal to 1, then x is just equal to cosine of theta, and y is equal to sine of theta, right? So that's what we learned. So this right here, x comma y, is now cosine theta, sine theta. So sine of pi over 6 is equal to root 3 over 2. Cosine of pi over 6 is equal to 1/2. So what I like to do with my unit circle is just focus on these 3 triangles. So first one was pi over 6. Now we have this angle measure here of pi over 4. So if I draw that purple triangle over here on its own, this is pi over 4. So that's an isosceles right triangle. So I'm trying to get this ordered pair. So what is this ordered pair up here? Well, in geometry, this is a 45, 45, 90-degree triangle. And in geometry, you learn that this is 1, 1, 1 root 2. Well, we can't have a radius, or I guess what we did in geometry is we did x, x, x root 2. But we have to have a radius equal to 1. So if x root 2 has to equal 1, then my x has to equal 1 over root 2, or root 2 over 2. You need to recognize both of these, right? So this length here is root 2 over 2 and root 2 over 2 for this purple triangle. So this ordered pair is root 2 over 2, root 2 over 2, or 1 over root 2, 1 over root 2. And then for my third triangle, it's the same as the red one, except it's flipped. So the longer leg is going up and the shorter leg is here. So this is an angle of pi over 3, which is equal to 60 degrees. So I'm going to start here with my 1/2. This is 1/2 root 3, or root 3 over 2, and this is 1. So this time I'm going to cross my x-axis 1/2 and then up my y-axis root 3 over 2. Now, when I do questions like the ones below here, all of these questions down here, what I do for me, it makes it easier, is when you go around this unit circle, all of these ordered pairs are going to be these ordered pairs, except the signs change, right? Because now we're going left and up. So all my x coordinates will be negative, my y coordinates will be positive. In the third quadrant, we're going to go left and down. So all of the coordinates will be negative. In the fourth quadrant, we're going to go right and down. So the x coordinates are positive and the y coordinates are negative. So the only thing I put on my paper usually is I do my pi over 6, put the ordered pair, which we saw up here is root 3 over 2, 1/2. I put my pi over 4, which is 1 over root 2, 1 over root 2, or root 2 over 2, root 2 over 2. And then I put my pi over 3, which I know is the reverse of my pi over 6. So when I look at this question, I just say to myself, okay, this angle is in which quadrant? Is it in quadrant 1, 2, 3, or 4? Well, 2 pi over 3